Students, I'm going to have you watch a 6 to 7 minute quick video, and it's an experiment where they have designed an apparatus to filter the salt out of water. Now, several things I want you to think about and what will be in your discussion. So I want you to be able to explain how the potato uses the principles of diffusion to measure the salt concentration in the branch samples. So you will write about that in your discussion. But then while you're watching this, I also want you to think about the design of this experiment, because we know by no means any method is going to be perfect and that there's going to be a lot of room left for improvement. So I want you to think about things that are said during this video or things that you see. Do you think this is bogus? What did he do wrong? How would you do it differently? How should he have done it? Is it what he said was accurate? What should he have said? And what would you ask it if you could do? So I want those questions and answers kind of in your critical thinking in there in your discussion also.
This is a branch that I cut off a pine tree. Some scientists did an experiment where they tried to use a branch just like this to filter bacteria out of contaminated water to make it drinkable, and their experiment worked. There is a huge amount of water on our planet, but there are things that make it undrinkable. One of them would be pathogens like bacteria, but the big one is that most of it exists as salt water. 70% of the earth is covered by oceans, and we can't drink that water because it would actually dehydrate us. To make it usable, the salt would have to be filtered out somehow. So I was thinking, if a branch like this could filter out bacteria, maybe it could filter out salt as well. It's a long shot, but the purpose of this experiment is to try to make a saltwater filter using a branch like this. To start the project, I had to go get branches to do the filtering. I wanted to try 2 different types of trees, so I got a branch from a pine tree and a branch from an oak tree. I shaved the bark off the branches so we were just left with the xylem, and then I cut them into these little pieces which are going to serve as our filters. We're going to take this stick and wedge it in this piece of vinyl airline tubing. To make sure that the water only goes through the stick, we're going to secure it with some hose clamps. And then we're going to take that and put it on this 2-liter pop bottle that's going to be holding our salt water. It really won't just drip through the stick. We're going to need some pressure to help it along. So we're going to drill a hole in the top of this pop bottle and put this bike valve in there. When it's all sealed up, we'll take the bike pump and pump it up, and hopefully we get some water flowing through the stick that might have no salt in it. The oak is already finished, but the pine has dripped maybe a few milliliters. Even if it filtered out the salt, I think I would die of dehydration before it was able to filter enough water to drink. The part of the tree that we call wood is xylem. Xylem consists of vessels that transport water and minerals from the roots up to the rest of the plant. And that's the part that might be able to do filtration for us. Xylem consists of 2 different types of cells: vessel elements and tracheids. The vessel elements pretty freely allow water and minerals to flow through the plant, but the tracheids have very, very small openings between them called pits. The pits that act as passageways between the tracheids are extremely small. So small they were able to stop bacteria from flowing through. But sodium and chloride ions from salt water are much, much smaller than bacteria. However, we're going to use this to try to attempt to filter them out. Well, it took a few hours, but all of the water is finally filtered through both of the sticks. And now we're going to do a taste test, and hopefully it tastes like water right out of the tap. First the oak and then the pine. Well, that's a bummer. We didn't save the world on this one because the water is still salty. So I think we're going to have to try to find a way to figure out if any salt got removed out of these filters. So give me a minute, I'm going to come up with a way to test how much salt is in these versus how much salt it started with. All right, this is going to be really low tech, but it should work. I've got 3 different groups of potato slices, and they all weigh 29 grams exactly. It's not the fact that they are potato that's going to help us, it's that these are cells. And water will move in and out of cells depending on the solute concentration outside of the cell versus inside. That's osmosis. So what would happen if I put these in that salt water is water would leave these cells, making them weigh less. Now, if we put the same amount of potato slices in our filtered water and less water moves out of them, that would tell us that we actually filtered some salt out of the water. So we're gonna put these in each of the different waters, wait about 20 minutes, and then weigh them at the end to determine if we were successful at filtering anything out. Let's see what these potato slices can tell us about our filters. First, we'll just measure the regular seawater, and we'll dry the slices to make sure that we're only measuring the potato and not the water stuck to the outside. Slices in the seawater started out at 29 grams, and they are now 25.4 grams. So they did lose weight, and that means that water moved out of these potato slices into the seawater because there were less solutes in the potato than in the seawater. So that means if the potato slices in the filtered water weighs more than 25.4 grams, then we were successful at filtering out some salt. So let's check those now. Here go the oak slices. The magic number is 25.4. 25.3. So I would say, based on our kind of rough techniques, that is identical to what happened in the seawater. So the oak didn't filter out any salt at all. From the pine filter, our last shot, 25.4. 25.9. Well, that is a little bit more, but I don't think that's a big enough difference to really say conclusively that the pine branch filtered out any salt out of our seawater. It seems pretty clear that xylem is not able to filter out salt. And it's probably because the salt is just too small. Even though these pits were small enough to filter out bacteria, salt ions are so much smaller. And I think instead of little holes, what you would need is an actual membrane that might filter them out based on their charges instead of their size. But at least we gave it a shot, right?